Hello everyone, welcome back to the channel. So today we are trying to solve lead code problem of the day, which is 1353 minimum number of events that we can attend. Let's have a look at what the problem statement says. It says you're given an array of events where events of I consists of two things. So an event consists of the starting day and the ending day. Now, for example, let's say that this is one event that we have. So it starts at 1 and it ends at 3. Now, what does that mean? It means that the event consists of 3 days. So it's going to take place at day 1, at day 2, and at day 3 as well. Alright. Every event I starts at a start day I and ends at end day I. Perfect. You can attend that event I at any day D where D is in between start and end time inclusive. That means if you want to be a part of, for example, let's say this is event ABC. If you want to be a part of this event, you can either attend it at day 1 or day 2 or day 3. So it's completely your choice. All right. Now the thing that we should keep in mind is that in a single day you can only attend one event at any time. At basically day in a certain day D, we can only attend just a single event. All right. Return the maximum number of events that you can attend. Now, if we take a look at the test cases that we are given, the example test cases, I that, like just like when you have a look at what the test cases are, the first approach, the very simplest approach that comes up into my mind is obviously a greedy one, right? So what I'll try to do is I will try to attend as many events as possible as early as possible. All right, so what I'll do is I'll attend this event on day 1, this one on day 2, and this one on day 3. Perfect. So I can attend all the 3 events, right? Similarly, what I'm going to do is that I'm going to attend this particular event at day 1. All right. Now you see, if I attend this particular event, this one at day 2, that means I won't at all be able to attend this event, isn't it? I won't at all be able to attend this particular event. So what I'll do is I'll say, okay, hold on. I will say to this event, hold on. What I'll do is on day 2, I will attend this particular event, right? Now, why am I saying so? Because this particular event, which consists of days 2 and 3, I can still attend it on day 3, isn't it? Can still attend it, and then since day 4 is still left, on day 4 I can attend this particular event. So the answer therefore to this particular test case is 4. Now let's think of a even better example, which is going to make the concept, which is going to sort of lead us to how the solution is going to be built. All right, so let's focus on this test case. Now, 4 of the events that we are talking about in this particular test case are one-day events. So they can only be attended on a single particular day. So on day 5, you can attend this, on day 6, you can attend this, on day 7, this, and on day 8, this particular event. Now, this particular event has a very large range. So it can be attended on either of these days, isn't it? Let's say that we have 4 as well. So in this sort of a scenario, in this sort of a circumstance, what's going to be your approach? See, what point I'm trying to make is intuitively you're going to give a higher priority to those events which have a shorter span. Okay, which have a shorter span, because if you think about it, you have less choice in that scenario. You have less number of days to choose from. You see, in this particular event, let's say that this is event 5, you have a lot of choices, right? So you can either attend that event at day 4, 5, 6, 7, 8. You have a lot of options. But then in the rest of these events, all these single day events, you have very less choice, isn't it? You have very less choice. So for example, let's make this particular one a 2-day event. All right. So what would you prefer? You would prefer that, okay, on day 5 I'm going to do this event, and this one, okay, this one can be done on day 4. Why not? This I will do on day 6, this I will do on day 7, this I will do on day 8, and ultimately at the very last on day 9 I'm going to attend this particular event. Why? Because in this event I have a lot of leverage. I have a a lot of options, right? So now you have a very good idea of where actually we are trying to where actually we're trying to head in terms of what approach is going to be we're going to need in order to solve this problem. So you know what we'll do is we will create two variables, a minimum time variable, and or let's say a minimum day variable and a maximum day variable. Okay. Now, what the minimum day variable is going to tell me is what it's like the least number of day. So the earliest day that I can attend an event. In this scenario, you can see very clearly see that minimum day is equals to 4. And in this scenario, you can very clearly see that 9 is the last day at which you can attend a certain event. Okay, so these two variables are going to help. Now, then what I'm going to do is I'm going to iterate for on 4, 5, 6, 7, 8, 9. So I'm going to iterate from 4 to 9. All right. And what I'm going to check is which event would be the most suitable for that particular day D. All right. So for the fourth day, what would be the most suitable event for me? For day 5, what would be the most suitable event for me? And you see, this is something that we need to take into account. An event which starts, let's say, an event which starts on day X. Let's say we have two events which start on day X. Now, one of them ends on the same day. Another one ends at X plus 2. Another one ends at X plus 5. So we have three different events. On day X, which option are you going to go for? You're obviously going to go for X plus on this option, right? Why? Because X plus 2 can be done on either X plus 1 or X plus 2, right? You have a choice because it starts at X and it ends at X plus 2. And on this option, you actually have a variety of choice. You can either do it on X plus 3, X plus 4, X plus 5. So you have actually 5 days on which you can attend this event. But this particular event, the first one, can only be attended on a single day. So it would be the best for you to just go and do it on the same day, right? What we are saying is we are going to prioritize those events which end early. So this early ending is at most important to us. And now, since we are talking about priority, since we are on the topic of priority, which data structure comes to mind? The first thing that comes to my mind is a priority queue, isn't it? A priority queue. But then how exactly are we going to use it? Let's see. So what I'll do is, after having calculated minimum day and maximum day, since I have this range now, I will sort the array. Alright, so what's going to happen is 4 comma 9 is going to come up somewhere, somewhere over here. So I'm going to sort based on the starting day. Now, why am I doing so? It's actually pretty obvious, isn't it? Because what I want to do is I want to go day by day. So I want to see which event starts at day 4. All right, I want to see which event starts at day 4. What I'll do is I'll have a priority queue, and now the question is whether I'm looking for a max heap or a minimum heap. You see, I am looking for ending times which are as less as possible. Ending times, let me write that down. That is very important. Ending times which are as less, or you can say as short as possible. So it's obviously going to be a min heap. Now, since my I, let's say this is an I pointer, or let's say even better choice would be, let's say that this is a D pointer, it tells me what day it is currently. Now you see, when you are at day 4, you can attend this event as well and this event as well. So what I will do is I will push their ending days into the minimum heap. So what I will do is I will push 9 over here and I will push 5 over here. Right. Now, when I see this particular day, since I'm at day 4, I obviously cannot attend this event. Alright, perfect. So this is step 1. Step 1 is seeing which events can be multiple. Start at day D. Alright, start at day D. Now I have to make a choice either to go with 5 or with 9. So what I'm going to do is step number 2. Step number 2 is going to be I need to decide now whether I should go with 5 or whether I should go with 9. I'm going to do is I'm going to pop this 5, meaning that what I'm doing is I'm actually preferring this particular event and I'm going to do this one on day number 4, right? So I'm going to pop this and I'm going to increment. Let's say I take a count variable initially which is 0 and I increment it to 1, meaning that I have attended one event right now. Now then what's going to happen is my day is going to increment. Now I'm at day 5, so I can attend this event. Okay, so the ending day for this event is 5. I'm going to push that inside the minimum heap. When I come to this particular event, I see, no, okay, I'm at day 5 right now. I'm at day 5, but this event starts at day 6. I cannot attend this. Perfect. Which events start at day D? Done. This step is done. Now I need to decide, okay, should I do this particular event right now or should I do this one? And I'm obviously going to do with this. I'm going to go with this one, right? So I'm going to pop the 5 out of here and I'm going to say that, okay, on day 5 I'm going to do this event and I'm going to just increment my answer by 1. Perfect. Similarly, the day gets increased by 1. I'm at day 6. Okay, I can do this event on day 6. I'm going to push the ending time inside the priority queue, the minimum heap. Perfect. Then when I reach this position, I see 7. Okay, I cannot do this on day 6. Similarly, I pop the 6, increment the count by 1, and simulating. What I'm doing is basically simulating that on the 6th day I did this particular event. Similarly, on the 7th day this one, on the 8th day this one, and ultimately on the max day I'm going to do this one. So what we'll be able to do is we are in a position to attend all the events that we have. So this looks good enough, but there is still one case that we haven't thought about, and let's see what that is. All right, so let's say that we have this sort of a test case where our minimum day is 2 and the maximum day is 7. So these are all the days that we have. Initially, I'm going to be standing at day 2, and then on day 2, I can do these two events. We know that for a fact. So I'm going to push 3 inside the priority queue and then 2 inside the priority queue. Now, step 1 is done. I right now standing on day 2, I cannot do this event, right? So I'm going to then decide that there's going to be a decision moment for me, and I'm obviously going to pop this 2 out of the scenario, and I'm going to say that, okay, on day 2 I did this particular event. I'm going to increment my answer by 1. Then I'm at day 3. Okay, so I can now do this event. I'm going to push 3 inside of here. I can do this event as well. I'm going to push 3 inside of here, but I cannot do this event. Makes sense, right? I cannot do this event. Makes sense. Now then again, I need to decide which event should I do. So I'm going to pop this 3 out of here, and I'm going to say that, okay, on day 3 I did this particular event. Perfect. Then I am on day 4, and this is the point that I actually want to put in front of you. I am currently at day 4, and these two events, what are these two events, by the way? This one and this one. Their ending date has already been crossed. I am at day 4. These two events ended at day 3. What I need to do is pop both of them out of my priority queue. Okay, so this is something that you need to keep in mind. Ultimately, I come on day 5. I see, okay, I can do this event now. I push uh, the ending date inside of it, then I pop it out. I increment my answer to actually 3, basically, because I did this event as well. So on day 2 I do this, on day 3 I do this, and on day 5 I do this. So the overall answer is going to be 3, right? So having said that, now we are actually at a pretty good place in order to write what the code of this approach is going to be. So let's have a look at that, right? What I'm going to do is I'm going to take first of all n as event size. Now I have a max day over here. Similarly, what I can have is the minimum day logic as well. So let me just very quickly write that down. Okay, so what I'm going to do is int min day, and I can assign it a value of, let's say, int max, and just let me copy and paste this particular code. And what I'll do is I will just say minimum of min day, and let me copy and put it over here as well. So what's going to happen is I'm going to have, let me change this as well, because minimum day is going to be based on the starting point. The maximum day is, it's going to be based on the ending point, and the minimum day is going to be based on the starting point. Then what I need is actually a priority queue. So I will have that, a priority queue which is a minimum heap. So by default, a priority queue is a max heap. Let me convert that into a minimum heap by providing these additional parameters. I'm going to have a count uh, as the ultimate answer that I return. And what else do I need to have? Am I missing anything out? I have the minimum heap, I have the count, and that's, I think that's it. Perfect. So then what I need to do is I need to iterate, let's say for int, you can say for int d, but I'm going to say I because that is more familiar to me. For int I is equals to minimum day, I is less than equals to maximum day, and I plus plus. So basically I is your current day, I is the day which you are currently at. I am going to see, oh, I forgot, very important thing, we need to sort the array as well. So sort events dot begin, before we proceed further, events dot end. Perfect. So we have sorted the array based on the starting time, and now we are going to uh, write down our logic. So what we are going to do is I actually need two pointers, right? I can't just work with just a single pointer. Why? Because there is one pointer. So if I go to the very beginning of this test case, if I go to the very beginning, when I'm at day 2, when I'm at day 2, so there is one pointer which keeps track of what the day is, but then there is another pointer j which keeps track of how many events I can do on a particular day. So I can do this event, perfect, increment your j. I can do this event, perfect, increment your j. I can do this event, no I cannot. So I need to have another variable over here which I will call as j, and which is going to be initially at 0. So what I'm going to do over here is I'm going to say, okay, um while events of j of 1, so the ending time, no, not actually the ending time, the starting time, when the starting time is let's say less than equal or equal, basically when it's equal to what, to the current day which is I, then what you need to do is you need to push the ending times. So you need to push ending times into the minimum heap, into the priority queue. What I'm going to do is I'm going to say pq.emplace it. I can say pq.push as well, but then emplace is an efficient way of doing the same thing. You can look it up, what's the difference between emplace and push. So pq.emplace events of j of 1, perfect, this makes a lot of sense. I push the ending time inside the priority queue, and what I'm going to do is j plus plus. Now since I'm incrementing j, I need to put the safety condition over here as well, that j should not exceed n. Perfect. Then the second thing that I'm going to do is this thing, the safety check that we saw in this particular test case. So what I'm going to do is I'm going to see, okay, it shouldn't be the test case that first of all your queue shouldn't be empty. Obviously your queue shouldn't be empty, and then if it's not empty, it shouldn't be the case that the element which is at pq dot top is what, it's less than the current day. So over here what was happening is, you see, I had 3 3 and 3, but then my current day was 4. So if you have pq dot top, and if it's less than the current day, just keep popping until and unless you have an event, an ending time at the top which is less than or equal to, or you can say which is greater than or equal to what the current day is, right? Perfect. Now if still you have something, if pq is not empty at this point, then that means that on this particular day, you can do something. So what I'm going to do is, first of all, I'm going to increment my answer, and then I'm going to remove the element, right? So if the priority queue is not empty on a certain day, I can do a certain event on that day. And what am I going to do? I'm going to choose the earliest ending. That is why I made the priority queue in the first place. So I think that's it. Ultimately, what we do is we return our count. Let's see if it passes the example test cases. I should hope so. No, count plus plus. Sorry, count plus plus. Right, it passes the example test cases. Let's see if it passes all the other ones as well. And then we're going to have a look at the time and space complexity. It does. Now, if we are talking about the time and space complexity, then obviously, first let's talk about what the time complexity is. So you have an array which consists of n elements, and you're putting all of them inside the priority queue, right? Inside of a for loop. You're putting them, ultimately you're putting them all in the priority queue. So that's n log n time complexity. And then since you're taking a priority queue extra space, that is O of an extra space, right? So I hope you found the video helpful, and I will inshallah see you in the next one. Till then, take care.